Okay, we're getting back into our inequalities and two variables. And instead of looking at just the linear ones, we'll look at some that might be nonlinear. And that's the first example that I have here. Now we're going to approach it the same way. We're going to look at it as if it was an equation. And then we're going to look at that as a boundary, in this case not a boundary line, but a boundary curve. And then we'll determine if the curve is going to be solid or dotted, just like we were doing with the lines in the previous video. And then we'll determine where to shade. So the first things first, I'm going to rewrite this as an equation here. We're going to graph the solution set. If I rewrite this as an equation, I get x squared plus the quantity y plus 1 quantity squared is equal to 16. That is a circle. The center is at 0, -1. 0, -1 right here, and my radius is 4. So I'm going to go from here up 1, 2, 3, 4, to the right 4, at least I'm going to approximate it, there we go, to the left 4, and then below 4 here. 1, 2, 3, well, one more spot there, 4. And then I'm going to do my very best to make it look like a circle. And this is why I use graph paper, so that I can already see how some of these are longer than some of these over here, so it's going to probably look more like an egg. But now, before I draw my circle, I look back to my inequality and I notice that it is not it does not have the equal to, it's a less than. So the circle that I'm going to draw is going to be dotted. So I'll do a dotted circle here. And kind of egg-shaped, like I was afraid it was going to be. So now, I'm either shading the interior region or I'm shading the exterior region determined by a test point, just like before. And since 0, 0 is not on the curve here, I'm going to use 0, 0 as my test point. I'm going to plug it back into, not into the equation, but into the inequality. I have 0 squared plus the quantity 0 plus 1 quantity squared is less than 16. This is 0. 0 plus 1 is 1. 1 squared is 1. I have 1 is less than 16, which to me is a true statement. So since 0, 0 came from the interior of the circle, this dotted circle, and I made it true, I'm going to shade the interior. Of course, if it had made it false, then I would have shaded the exterior. But that's my solution set represented with this graph to this inequality in two variables. Now, we kick it up just a little bit here by looking at systems of inequalities, and that of course the system is two or more inequalities in the two variables. They form a system. I have one here with 2, I have one here with 3, and I'm going to look just like we did with systems of equations by graphing them on the same set of coordinate axes here, on the same Cartesian plane. So I'm going to do this first. I'm going to use different colors here. Bit of an advantage when you're using markers. I'm going to do this first one here in black, if that's a color. And I'm going to write y equals, remember I always start with the equation so you can see what the boundary, in this case the boundary line is going to be. And that is a line with slope -1/3 and y-intercept at 0, 1. So 0, 1 is right here. Slope is -1/3, is down 1 to the right 3. And I'm going to graph this line here in just a second, but I go back and I check to see if it's a dotted line or a solid line. And it's a dotted line because there's no equal to. So I'll get my yardstick over here and I'll line it up, and hopefully it won't move on me. That's one of the disadvantages of doing the work on the board here instead of just a piece of graph paper. Okay. And I have to determine now if my graph is the half plane that's above this dotted line or the half plane that is below the dotted line. So I take a test point not on the line. My favorite is 0, 0, and I'll go back to the inequality here and plug 0 in for x and 0 in for y. And I have 0, this is, of course is all 0 here, plus 1 is 1. That's a true statement. Since 0, 0 is below, I'll try to neatly shade below. I know you guys can do a lot better that I can shading these in, so I hope to see some nice clean looking graphs. Now I'll do the second one here. I think I have my blue pen, I do. I'll do this one in blue. Okay, now I'm going to write this as an equation. And I'm going to put it in slope-intercept form by adding 2x to both sides. And what's convenient about that is now I know what my slope and my y-intercept are. My slope is 2, my y-intercept is 0, 1. They happen to have the same y-intercept as the first one. My slope is 2, which is like rise over run, 2 over 1. And now I'm going to get my yardstick here. Because of the equal to, I know that this line that I'm going to graph is going to be a solid line. And again, try to be neat with this so that it doesn't shift on me. Fill up that graph. Okay. And I have this half plane, which is kind of down and to the right, and this half plane, which looks like it's kind of up and to the left. I pick a point not on the line, like 0, 0. I substitute 0, 0 into here. Negative 2 times 0 plus 0 is less than or equal to 1. 0 is less than or equal to 1. That's a true statement. And since 0, 0 just barely is to the right, I shade to the right. Now I've got the shading lines going this way, so instead of trying to put the shading lines in the same direction, I'll kind of go perpendicular to it if I can here. So hopefully what will happen is we'll get a bit of a grid here. And you can see where the shading overlaps. Now we're looking for where the shading overlaps because the shading overlaps in this region where all the ordered pairs, when plugged back into both inequalities, will be true. It will satisfy both inequalities. And this is going to be your graphic solution of the system of, in this case, linear inequalities in two variables. Infinitely many points, can't list them all. Draw a picture. You know, a picture is worth 10,000 words, right? Well, in this case, it's worth infinitely many solutions. Next one, over here, I have two linear inequalities and one nonlinear. I'm going to have three, so I need a third color, I suppose, to do this. I see a red pen there, that'll work. But I'll start over here with this one. If I write the related equation, x squared plus y squared equals 25, I have the equation of a circle with center 0, 0 and radius 5. So 5 to the right, 5, 1, 2, 3, 4, 5 upward, 1, 2, 3, 4, 5, 5 downward, 1, 2, 3, 4, 5 to the left. And again, my scale isn't perfect. My tick marks, I didn't use a measuring device. I just kind of freehanded it. That's why you use graph paper, because that way the graphs look decent. And this is going to be a solid circle. Well, we'll try. And not great. Not terrible, but not great for me anyway. And I pick a point that's not on this, say, I don't know, 0, 0. Do you see it coming? 0 squared plus 0 squared is less than or equal to 25. 0 is less than or equal to 25 is true. So I'm going to shade the interior of the circle. And for whatever reason, I decided to make them too close together here, so this is going to take me a little bit longer. I want to go beyond it. I have more sympathy when you're shading these if you are a little bit shy of missing it as compared to going past it. So be as neat as you can, and I have that circle. There's the first one. Alright, this time I'll go with the red one for the second one here. I write the related equation. The opposite of x plus y is equal to 1. Add x to both sides. Y equals x plus 1. That's a line that has slope 1 and y-intercept at 0, 1. Slope 1, up 1 over 1. Okay, and it is a dotted line, so I'll get my yardstick and try to line this up best I can. very well drawn. Sorry about that. And this is dotted. Oh, I think I missed. Yeah, I missed a little bit there. Kind of use a little bit of the marker there to kind of fill that in. And now I either shade below or I shade above, take a test point, and as you can see 0, 0 is kind of below and to the right. I plug 0, 0 in, I can kind of see this coming. That's true, so I'm going to shade, let's shade it this way. And you can see where you have some overlap. Okay, one more to go. Grab my other marker. Y is less than or equal to -4. The related equation y equals -4, which is a horizontal line. Way down here, 1, 2, 3, 4, and there is an equal to, so it is solid. And this is my line right here. It separates the plane into the half plane here above and the half plane there below. Pick 0, 0, plug 0, 0 in. 0 is greater than or equal to -4, which is true. So 0, 0 is up above it, so I shade above it. Now, this is getting messy. Good thing I use different colors. Kind of angle this one off a little bit. Whoop. Now, when you have one, especially if you're using a pencil, not colored pencil, so they're all kind of the same, you may want to take the time to kind of emphasize where they overlap, because as you can see, they clearly overlap, and so on. I'm going to try to do that. I've got one more color pen here. I got a green one. I'm going to try to do that right here because it looks like they overlap right in here. And, whoops, went a little too far there. And you can see where the three graphs overlap. That's kind of emphasized there with the green ink there. And that would represent the solution to this system of three inequalities that involve two variables, two of them linear, one of them nonlinear.